Welcome everyone to Every Element Ever. We're here with number 2, our boy Helium, as you can see. The beautiful element Helium. As you can see on the board here, what is Helium? I have some notes for us here, blah blah, to take on Helium and what it is and what we can learn about this amazing element number 2. That is not exactly on Earth, it's not very common on Earth, but it is very common in the universe. The second most abundant element in the universe behind hydrogen. Here we go. So helium on here this is what it'll look like when you guys look on your periodic table. You're gonna see this big number 2. This refers to the atomic number, which refers back to, of course, the number of protons. The number of protons determines the element that it is. Protons give the element its thing, its weight. It's who it is the number of protons that the element has. That's what makes an element an element. Like a tuna sandwich, the tuna is what makes a tuna sandwich. I don't know. Not a great analogy, but just go with it. So anyway, we got atomic number 2 for helium here. So it's 2 protons we got there. Then we got our 2 electrons going around. Then we also have, in most cases, 2 neutrons. Neutrons have a neutral charge, thus the name. Pretty cool. Here's a little drawing I did of helium to give you guys an idea. So unlike hydrogen, which remember has 1 proton, 1 electron in its base form, helium here is a lot more, there's a little bit more stuff going. It's actually pretty simple, but it's more complex than hydrogen. So here's our 2 protons here with their positive charge, and here's our neutrons with their neutral charge. They're kind of lumped in with the protons. And around that is their 2 tiny electrons, with the electrons are orbiting around the central nucleus, and they have this kind of ring in which they move around that central nucleus of protons and neutrons, and they're going around like this. Pretty beautiful, very elegant. This formation, the way it comes out is, you'll notice helium on the periodic table is all the way over on the right, opposite of hydrogen. Well, it's known as a noble gas. Here we have a noble gas, or as I call them, an immobile gas. Not that kind of gas, but well, that's another discussion. So it's an immobile gas. So basically, I think of it as it's not moving much. A noble gas is an immobile gas. If you follow along the line of the periodic table all the way down, helium's our first noble gas. That whole line following down are all noble gases. They're very immobile, which means they're non-reactive, non-flammable, and they have a couple of other traits that are very fascinating with them. One other trait that, the reason they are non-reactive, they don't react, unlike hydrogen, which is very reactive, it's really because of this formation in their atomic nucleus. The fact they don't want to give up their electrons. It's very stable. They basically have this outer shell here of the electrons is called the valence shell, and they're known as like valence electrons. Like this outer ring, this outer shell is called a valence, known as valence electrons. And this outer shell, they basically don't want to give up their electrons. They're very stable. They're very happy where they're at. They're in their comfort zone. Helium and all the noble gases are in their comfort zone. Leave them alone. Don't bother them. They're not going to get in your way. They ain't going to mess with you. So that's what makes a noble gas, is that formation. It doesn't want to give these up. And the electrons with the positive charge of this, it's kind of created this stability, and there's no other electrons that it wants to fill up in this shell. And so it's like, I'm happy where I'm at. Leave me alone. Don't touch me. So that's what helium's doing. Down here we have the atomic weight, which you can see helium has a lot more weight than hydrogen, which I actually don't know off the top of my head the atomic weight of hydrogen. You can see 4.002-ish. That atomic weight is basically telling you kind of a general idea of that's the weight of the protons with the neutrons. I'm actually not sure. I think electrons might weigh something. It's very minuscule. I don't know if that includes the weight here of the atomic weight. I know it's mostly the protons and the neutrons. And those neutrons really add a little bit of weight to it, so they give it a little extra bulk, if you will. And also, a fun fact that you guys are probably familiar with, but is much less dense than air, which is why it's perfect for balloons. So balloons, in case you haven't noticed, if you breathe in some helium.
If it sounds like this, it's because the helium in the balloon basically replaces the air, the oxygen, and it increases the frequency of your voice. And so helium makes it very squeaky and very high pitch. And so it squeezes the wavelength, it compresses it, and it's less dense. So it just goes like that, like that. So it's a weird phenomenon, but a fun one for sure, at party tricks. So because it's less dense, it basically decreases the density of your voice and it gets very, very light. And all of a sudden the frequency goes, the wavelength gets shorter, frequency goes through the roof. Very high pitch, very fun. So less dense than air, so obviously they're really good for balloons. They're also great for MRI machines, or helium is used in MRI machines, I believe because of its low melting boiling point. An additional fact here of our wonderful element helium all around us, mostly in the universe, not so much on Earth, but it is still here. The discoverers of helium. So we have here Pierre Janssen, who was a total dude, and this guy Joseph Norman Lockyer, also another dude. I believe Lockyer here was an astronomer, but they kind of co-discovered the element of helium, but they didn't know precisely what it was. They found this thing in the late, I believe it was in the 1860s, in the late 19th century. They looked at the spectral lines of the chromosphere from the sun, which is like the second layer of the sun. They looked at these lines from the sun and they noticed this weird, I believe, yellow line on the spectrum of the spectral lines of the sun. They're like, what is this? It was an unknown element at the time, but they had first witnessed some observations on it. Well, come to find out, this other dude, William Ramsay, this boy right down here, a chemist, a noted chemist, he actually did some work with the mineral, and he was actually able to extract some of the gas, this weird gas, and he saw the lines as well. And he noted and observed it, and they ended up naming it, I believe it was Ramsay or Lockyer named it, but they ended up naming it Helios, god of the sun, because remember, they actually observed the first instances of helium from the sun, the spectral lines from the sun, this fingerprint of this element that they didn't know what it was. And so these two guys, Pierre Janssen and Joseph Norman Lockyer, first discovered it, first found out about this weird element that they didn't know what it was. Much like hydrogen, it's tasteless, odorless, colorless, all this less stuff. And they discovered it first, and our boy William Ramsay here actually discovers it on Earth. He extracts it from a mineral. Name it Helios, god of the sun, because it is going to come from the sun. How about that? That's why it's helium. Helios, god of the sun. And just like our boy hydrogen, I had to draw our little sun here. Helium is a big boy staple in nuclear reactions, nuclear power plants. Nuclear fusion is a huge, big science idea. So when hydrogen crashes in together, makes fusion, it releases a lot of heat and energy. Well, it becomes helium. And so that's what the sun is doing. Every star is creating more and more helium. It's basically smashing hydrogen together, creating helium, smashing these basically individual protons. Basically, hydrogen is like this. Hydrogen is separate, and you have two little hydrogens coming together, and they come together, they squeeze, boom, smash in, forming helium. And so then we get a lot more helium getting stacked up into the sun. When it becomes helium, it shoots out a lot of heat and light, and creating the beautiful sun rays that we see and the light and the life that we have here on Earth. And so it creates the helium, and more helium gets pumped into the sun, and soon enough, once it's out of hydrogen, it will start burn off its helium. Helium will smash in there, create lithium and other heavier elements, and on it goes. So helium is an instrumental force in nature, instrumental force in nuclear fusion and fission as well, because you can also separate helium, which is great. Releases a ton of energy well with nuclear fission, which we've done mostly with the atomic bombs, but also with nuclear power plants. And there you have it with our boy helium. Some background information for you guys, some amazing work, discoveries. Helium is all around, it's very abundant in the universe, and not so much here on Earth. Hope you guys learned a little something today on the Baby Sagan channel. Please like, comment, and subscribe. Hit that sub sandwich button. You know what to do. See you next time.